So in this video, we're going to sketch the derivative of a cubic polynomial or a third degree polynomial. So here's a third degree polynomial. I don't actually need to know that it's a third degree polynomial, but it is. What we want to remember is that the derivative is just the function that describes the slopes of the tangent lines of a given function. So when we're sketching a derivative, we want to focus on the tangent line slopes for the function. So the first thing you do, kind of step one, is to look at the function you're working with and determine if there are any places on the function where the tangent lines would have a slope of 0. So constant slopes for tangent lines. So here at this peak, if I were to draw the tangent line to the function at that peak, I would get a horizontal tangent line, and a horizontal tangent line is going to have a slope of 0. Here, at this local minimum, I also have a tangent line where if I drew it, it would be a horizontal line. The line just touching the graph of the function right there would be a horizontal line and would have a slope of 0. So this tells us that at the x-coordinate at the x-coordinate for which the tangent line is horizontal, the derivative has to be 0 because the value of the derivative will be the slope of the tangent line. So I want to walk down to the x-axis right underneath that point at which the tangent line is horizontal, and I want to put a point on the x-axis, and I know that the derivative has to pass through or contain this point because the derivative will be 0 right there. Here I want to walk up to the x-axis, draw a point on the x-axis, and the derivative will need to contain that point because the derivative will have a value of 0 where the tangent line to the function f of x is horizontal. Then as an aid to graphing, as a graphical aid, I want to draw in, I'm going to dash in a vertical line through that point. And then I just draw in a vertical line through the other point I drew. So vertical lines at the places where the tangent lines had slopes of 0. And this is not needed, but it's an aid for sketching the graph. So the next step is I want to focus on tangent line slopes again. So here's the 0, here's the place where the tangent line had a slope of 0, here's the x-coordinate. Step to the left of it and look at the graph of the function and visualize tangent lines on that function. So for example, there's a tangent line, there's a tangent line, and then ask yourself the question, is the slope of the tangent line, or are the slopes of the tangent lines to the left of this point, are they positive or negative? Are they going uphill or downhill? And if I look at this tangent line right here, I see it has a positive slope here, a smaller number because the tangent's shallower, but that makes sense because the tangent lines are going to sweep around until they get to a tangent line whose slope is 0. So the key is to the left of this value of x, the tangent lines are positive. Step across this place where the derivative has to be 0 and look at the graph and say, hey, what do my tangent lines look like here? And what I want to notice is that to the right of this point, I have negative slopes. The tangent lines are downhill. So as I step across this dashed line, the tangent lines switch from positive slopes to negative slopes. And then I want to find the inflection point on the graph. So the inflection point looks like it might be right about here. And this will be the place where the graph either reaches a local minimum or local maximum. So I want to mark in any inflection points. And really the inflection point on the graph is the spot where the rotational direction of the tangent lines switches. So here I had another place where the tangent line had a slope of 0. Step over this value of x, look at the graph and say, are the tangent lines on this side of this vertical line, do they have positive or negative slope? And here I see they have positive slope. They're going uphill, so positive. So what this does is tells me that my derivative is going to start off positive, go to 0 right here, then it's going to go negative. It's going to have a max or min value at the x location, the x value at which the inflection point is. And then as I jump across this vertical line, the derivative will become positive again. So this is enough information now to draw a rough sketch of the derivative. The derivative starts positive, but it has to go to 0 right there where the tangent line had a slope of 0 on the graph. Now it has to be negative, so I have to pass through the x-axis until I get just below the inflection point. When I get below the inflection point, this will be the local minimum on the graph, and now I need to bend back towards the other 0. So I have to draw the graph back towards its other 0. As I step across this point, the derivative must become positive, so I have to pass through the x-axis to become positive. And then I'll draw my arrows on showing that my graph goes on forever. Again, this is a GeoGebra sketch, so it's missing the arrows that should be included on any hand sketches that we make. So here's a rough sketch of the derivative of f. It's a parabola, which isn't an accident. So the we're going to discover in the next homework that the derivative of a third degree polynomial is a second degree or a quadratic polynomial.